Hello. We're going to get going here in just a few minutes. We'll wait for some folks and I will check that we're going. Looks like Restream is going and it's happy. And YouTube is going and happy. Great. Hello, everyone. Like I said, we're going to take a little bit more time here. Let me just double check. Yep. Tuck to this window underneath. Now I got to sneeze. Darn. Here, I can mute myself. It's there. My sneeze is lingering. All right, say hi in the chats. Make sure you can hear me and see me. I know there's a little bit of a delay. Hi, Kirk. Thanks for dropping by. We're a little early. Hi, Eric. Looks good. Sounds good. Thank you. Thank you. I think this is blurry, but I'll fix it soon. Oh, and you can see like the refresh here as well. Fancy. Give away the plans. All right, one more minute and then we'll get going. Hi, Love the Factory. Thanks for stopping by. I started a little early too, so that's why I want to give folks a little time to realize it's whatever time it is in your time zone and that we're probably going. Oh, I'm excited for weekend. 11 o'clock in Paris, Gerard. Thank you for joining late in the evening. I try to be asleep by 11 o'clock now because I have a kid that gets up at 6:30. Like this week has been consistently 6:30. It used to be we'd get lucky and he'd do like after 7, but this week it's been consistently 6:30. Hi, Beata. Hey, Johnny. All right, then 1 minute is up, so I'll get started. Hello, everyone. My name is Scott. I work on CircuitPython for Adafruit. CircuitPython is a version of Python designed for microcontrollers, which are little tiny computers. They're also inexpensive. Here's an example of an ESP board. And then under this tin here, there's a chip there that has RAM and a CPU and a bunch of peripherals. You can see here that it's labeled as an ESP C6, which we'll talk about today as well. Hello, David, and DCD as well. Adafruit does open source hardware and software based out of New York City. I work remotely. I contract for them doing CircuitPython work out of Seattle. So if you want to support me, do it by supporting Adafruit. They treat me really well and have really shepherded CircuitPython along, which has been great. So you can do that by going to the URL adafruit.com. And then if you want to join the chat that's in the middle here, this is Discord and the lower one is YouTube. And the middle one here is Discord. You can join it by going to the URL adafru.it/discord. The benefit of that is the chat stays around. It's not tied to this video. And we also have CircuitPython-dev on there, which is where me and the other CircuitPython devs discuss the work that we're doing on CircuitPython. So if you're hacking on the core, which is something we do on the stream a lot, that's where you can get help as well. There's also help with CircuitPython channel for just help with CircuitPython in general. So as always, I'm happy to take questions. I like to make myself accessible and answer questions that people have about electronics, about CircuitPython, all that sort of thing. My kind of tentative plan is to start with an update on the IDF merge, which is last week we started merging in 5.1. And I spent the week working on that, basically. The 5.0 merge, 5.0 PR just got merged in today, which is very exciting. And I've made a PR for 5.1. So this week was a lot of finishing up what we started last week and then testing it on the ESP32C6 and the H2, which are two chips that are now supported by the IDF 5.1. So that's this board here is the C6. This is actually a sample one that they sent me, but I also have another slightly different one. This one, for example, doesn't have the sample. It's a mini instead of a regular module. And I did look at the RAM kind of version numbers, and they're the same. So I had an issue, and I thought it might be the sample being older, but it wasn't. It was another issue. Hi, C. Grover. So Taya says, is it deep C6 time? Yeah, so I got both H2 and C6 working. If we want to cover it, I figured I could just go through the PR and cover all the changes that were made in the PR. H2 is a little interesting to support just because it doesn't have Wi-Fi. So there was some like stuff I had to change in CircuitPython around that. But all in all, it wasn't too bad. 5.1, as we realized last week, was not too bad, and then the C6 and the H2 support were not too tough either. So in terms of stuff that we could work on, you know, as always, if you have questions, please ask them. But maybe we'll do the PR, and then I have two things on my desk here. One is RGB Matrix support. So here is a RGB Matrix I got going, and I think Microdev, who did most of the 5.0 work, said that they turned it off because it wasn't working on 5.1. So one task is to re-enable it. I filed an issue about that this morning. So that's one thing we could work on is testing RGB Matrix with 5.1 and doing any fixes to the underlying proto-matter library to do that. The other thing we could do is what's on the overhead here is Jeff has been working on what we call dotclock support. So there's these really nice displays, and this is another one, although this one's turns out to be a sample that doesn't work that well, but this is a 4-inch square display, and it's 720 by 720, which is more pixels than we normally have for the like SPI displays that we have. So I had to update that code for IDF 5, so I was testing it. And I confirmed I do get pixels here. The colors are wrong, but that's because this is a sample with the wrong pinout, I guess. But this display here should have correct colors, but it requires an initialization sequence that is not super easy to do. So there's work I could do to get this going, which I'm a little interested in. And then there's also the RGB Matrix stuff, which will probably be more, hopefully more similar to the work that I did updating the IDF, but we'll see. So Tyeth asks, what's the difference between i8080 displays and the dot clock parallel? I was hoping to add an i8080 based board. I don't know details about the Intel parallel displays. Yeah, so that's the short answer is I don't know. Dot clock is where it has like hsync, vsync, and the like all the bits of the color all in parallel. But Jeff's been doing most of this work, and I haven't dug super deep into it. So the short answer is I'm not sure. And I don't know what the difference is. And that's part of the reason I'm kind of like, I don't really want to do that. I feel like getting this initialization sequence stuff could be a little bit of a pain. It's kind of like one of those magical, like, when you get it right, it works. And I did try like some of the demo code from Jeff, but it didn't come up. So that's a little bit like, oh, there's more work to do there. It's a little tricky because the initialization sequence is done. It talks SPI to the display, but there's not enough pins from the ESP, so you have an I2C gpio expander kind of that bit bangs SPI for you. So that's a little tricky. Let's start by we'll go over this PR, and we actually should check the oh, I was gonna say the CI, but I can see here that the CI passed, which is great. So this is the PR for those of you following along. It's 8424, and this is the 5.1 update. So I figure I'd just do a quick go over of it to kind of complete the story that we started last week. Yeah, Beata says GPIO expander, ouch. Yeah, it's it makes sense in the sense of those pins you only need when you're initializing, but it's definitely more complexity. And that's the challenge with these dotclock displays, is that they just they're parallel, so they take a lot of pins. But they're much higher res. And the other thing is that unlike the smaller displays, the smaller displays have frame buffers, so they store all the pixels. Whereas these dotclock displays, you have to send the pixels every frame, all of the pixels every frame update. So that means that's why it's on the ESP32 with PSRAM, is that you use a huge chunk of the PSRAM for your frame buffer. And that's kind of the limit of my knowledge. I haven't done a lot of work with it. I kind of just interpreted the API to the new version. All right, so yeah, if you have questions, ask. Let's just go over this. I don't think it'll take too long. So I made just kind of a few notes about what the changes were from. So H2 is the first ESP without Wi-Fi, so we had to I had to make sure that the builds worked without Wi-Fi. Okay. There was one thing about where the MAC address was located, because we use that as the unique ID. They updated the compiler, so the code size grew a bit, especially on the C3s, which is riscV. So heads up, the easiest way for me to fix that was to disable BLE on C3s with too little space. I did that because it freed up a bunch of space, and the BLE support on ESP is not complete. So generally, people aren't using it, is my impression. Because it can't do particularly BLE HID, I think is one thing that people really want to be able to use it for, and unfortunately we just can't do that on ESP yet. There are a couple of fixes for compiler errors. It's updated to GCC 12. I think we saw this when we looked at the migration guide. The ADC and the DAC drivers were updated to a new API, and the C6 is only supported in the new ADC API, so I updated that. And in fact, that's one thing we could do, because I never actually tested it. I rewrote the code, but I never actually tested it. Should I admit that? Please, 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 if you want to help, test out the absolute latest builds and find issues, because I was thinking about this. I am not a great tester. I don't have very good test discipline, but I like fixing things. As long as I can reproduce them. So this is where other people can really help, is by testing. And people helping reminded me that I did want to talk, and this will be a tangent, but for those of you who know, Kattni is one of those folks that has been a part of CircuitPython for a long, long time. And today is her last day working for Adafruit. So it's a bittersweet moment. I'm excited to see what she does next, but she's also a huge part of what makes Adafruit and CircuitPython run. And she joined, I think, in 2017. So she's been like around the project a long time, and does a lot of the community work. So I wanted to say thank you, and it's going to be a different world without Kattni and CircuitPython. So we'll see. I wish her well. I'm excited. I'm excited for new things. I think it's always generally always a good thing for new experiences and to do what you want. So excited for Kattni to see what's next. There, I brought my own tangent, but it is something that I wanted to talk about, and it really did make me think of like, oh, you know, like what is CircuitPython without these people that I kind of just think of as core people to CircuitPython, and she's one of them. Okay, so going down this list, the last thing is C6 and H2 have a new RTC peripheral, designated the low power always on thing. So in places where we like talk to the RTC peripheral directly, I had to switch it to the LPA on. So we'll see that too. Okay, so it's 113 files, which I think the 5.0 was like 300 files, so this is pretty good. So one is okay, so here this is changing submodules. So we're using CircuitPython -5.1. Oh, now I have to. I got it that time. Sweet. Okay, CircuitPython 5.1. So this is changing where what version of the IDF we use, and there are a couple fixes that are in that branch that I had to do for 5.0. Thank you, DCD. And then this is actually a correction. We were using the ESP32 camera, our fork of it before. We just didn't have the Git modules updated correctly. Okay, so here we are to the Makefile. You can see we're adding the C6 and H2 targets and marking those as riscV as well. There's this weird thing that really annoys me, where the Bluetooth kind of blobs, I think, that are used for S3 are the ones that are on the C3 as well, and they don't have separate directory paths for the same. They just in their CMake like change it to the other thing. So this is like making the Bluetooth IDF target, and you can see we use it here on this include only, which is silly. Some includes moved around, so I had to update this. They did a lot of this like split the driver apart stuff. This is all stuff we wouldn't have to do if we were using CMake, but then again, like it's not too bad. It's not too bad to do. One thing that's weird about the C6 is that they have regular ROM. They have full newlib in there, not the nano version. So there's a newlib, and then there's newlib nano, which is meant to be smaller. But in the C6, they built the regular version of newlib and then put it in ROM. And so if you tell the build to use the nano version, it actually uses more code space, because then it's using the ones that it compiled. It's not using the ones that are in ROM. So that's what this is doing, is that saying like for everything but the C6, do the nano stuff. This is a change that came with new GCC, which is changing the architecture string for riscV. Here's two sets of ROM blobs. So these are linker script files that tell the linker what symbols the ROM has to use. And you can see here's for C6 and H2. And these lists are only based on what was missing in the compilation. There might actually be more ROM stuff that maybe I should look at that could save space too. Intro to libm I had to change. So MicroPython has its own version, but it didn't have float. Like I couldn't get float working. and so like not float, floor. And so I just switched it to using the regular libm instead. The C6 and the H2 use this USB to serial JTAG thing as well. So this is me factoring it out to the Makefile from the header file and being able to use it on what stuff we include. This was like not the C3 gets this p count and touch peripheral stuff, and I just switched it to doing some other make defines. Blah blah blah. I factored out the Wi-Fi binary blob stuff so that if CircuitPython Wi-Fi is off, it just won't include them. That's what this is doing here as well. So these are like the IDF components we need to link in when we have Wi-Fi. And then this is a trick that I found on Stack Overflow for basically mapping the target to the BLE implementation. Is that you do this fancy like macro kind of thing where you're reading the BLE impl of the IDF target and then saving that as BLE impl. It's kind of a little weird, but it's I think a pretty elegant way to tell it which one of these three, the ESP32, the C3 version, which is also the S3, or the libble, which is the C6, C2, and H2, I think. I did do C2 in here a little bit as well, even though I didn't test it because I don't have a board. But like where I was like looking for per target stuff, and if I ran across the C2 stuff, then I put it in there as well. Here's another example of like where the bootloader offset is. For H2 and C6, I didn't do C2, I guess. ESP, this is a compiler fix. It found that peer info.lmk was never null. And so I added this lmk set thing to be able to do these checks. So a lot of these board changes are going to be this moving the USB serial JTAG from the .h to the .mk, and that allows the Makefile to use it, which is nice. And then also on a lot of the C3 boards, like if it's a 4 megabyte, you'll see that BLEIO is turned off as well. And this is the vast majority of the files. And then there's also these header path changes, particularly GPIO, because boards are allowed to reset GPIO to a not default state in case they're attached to something. So the ones that do that will include this GPIO header. So that's why we see it there a lot. So here's a serial JTAG thing and BLEIO. This is turning off the console to the uart because I don't want that on that board. The qualia is this board on the overhead here that's talking to the dotclock display. I wrote the C2 support without having a C2. I don't think it's complete. I just, like in the cases where there was like a value from a value or something that was related, I would add it in, but it's not complete. I have a C2. The C2 is confusing because they also call it the 8684 for some reason. And I have a board in my cart at DigiKey, but it's not available yet. So I don't think C2s are really available yet. If you have a C2, let me know and you could do this work, but I don't know of anybody that actually has one. It was kind of interesting to see like a lot of these C3 builds to start to see like how many different boards use a C3, for example. And like, I don't know of any boards that use C6s either. So it's really early for, I think, the H2, the C6, and the C2. But I'll tell you, I'm excited to get a P4 in my hands, which is their performance chip that has no Wi-Fi. I think that's gonna be cool. It's got like DSI displays and stuff, so it's is going to be neat. And high-speed USB, I think, as well. They've started adding it to master, so it'll be in like IDF 5.2 maybe, which they haven't started yet. Someone in espressif has one. Yeah, they do. It's okay. We'll add it later. It's no big deal. All right, let's keep going through this. JTAG, BLE, GPIO. I deleted, so this is the Arduino Nano. It got like merged in at a weird time, and I redid this debug uart stuff, so I just deleted it kind of in the interim. Again, moving it out of mpconfig board and into the Makefile for being able to include files based on it. More of that. See, like this is the vast majority of it. You know, the other thing we could do today, and that I was meaning to do, is actually testing flash frequency. Because I think a lot of the Adafruit boards and non-Adafruit boards are not clocked as fast as they could, which will actually change the performance of them pretty significantly. So maybe that's a task we should just do after going through this PR, because then we could make another PR that basically speeds everything up, which would be cool. And I think we talked about that last week as well. But you kind of need to, at least, yeah, you need to test it some to make sure that it works, because you're like trying to speed it up, and the board layout and the module layout will dictate whether you're actually able to do that or not. Here's a new board. This is the espressif C6 devkit C, which is the one that is labeled sample here. So that's been added. I really like these dev boards. Like the S2s came in these salas with a single USB thing, but these new devkit, the M's and the C's with the dual USB, are really nice. And this dual USB is even like only to the native USB serial converter. It's not even to like the full peripheral. But I really like the dual USB on these boards. No USB VID PID because it's not full peripheral. Yeah, that's the C6. And there's also, so that's an 8 meg flash, and then there's also the devkit M, the smaller one, and it has 4 megs flash in it. It has a NeoPixel, and I'm running them at 80. You'll see that BLE is off here too. So the C6 4 megs are also not going to do BLE, I don't think. So here's the H2, and the H2 only goes up to 48 megahertz at the high end. So yeah, this is the top. Oh, this has BLEIO off. I didn't mean to do that because it doesn't have Wi-Fi, so I thought it'd fit. Let's just make it and see. Let's just see if we can undo that. I didn't mean to do that, but maybe I did it without thinking. How much space do we have? All right, we'll make that. Yeah, if you have a C2, let me know, or you could follow up, but I don't currently have one. There's C2 support in the IDF. I don't have a board to test with. They're not like that appealing for CircuitPython because they don't have that much RAM. But they are Wi-Fi, I think. You look at hardware and then see it says small, cost-effective, Wi-Fi 4 and BLE. But it's only 272K of SRAM. So like it's not that much compared to even the C3 is 384, I think. Oh, it's like, yeah, 400 total, but 384 probably that we can use. So it would be real tight. It'd feel like your Sandy 21, maybe, or maybe even less. And they don't even have the P4 up here yet either. It could be funny if someone built the C3PO with a ESP32C3. They could, for sure. TCD says, I remember when 32K was a lot. It was never like spacious for CircuitPython, but yeah, if you're not doing CircuitPython, then it's a lot. CircuitPython's much more memory efficient than CPython, but it's still not anything that was like compiled by a industrial or like a full desktop compiler. All right, and I'm gonna have to turn the AC on. There's no way I'm gonna go 2 hours if I don't turn the AC on. So sorry, I did run it before, but, and if like the weather, let me show you though, my weather updater. You can see here that today is sunny and warm, but it's all cloudy tomorrow and rainy all the rest of the day. So this might be the last time I need the AC for a while. Which I'm kind of like okay with, actually. I don't think it's too bad either. Turn it on. I'd rather have there be a little bit of background noise than me being like melting. Hi, Unexpected Maker. Just turning my AC on. Hopefully it's not too bad. The 5.0 IDF is merged into CircuitPython, and 5.1 is out in PR, and it adds support for the C6 and the H2 to it. Ty says, is it allowed to have a different default frequency for custom board definitions I2C bus? I think that would be fine. It's probably maybe not what you want, but it's probably fine. It's certainly fine if the this is something we were just thinking about, because like getting the displays initialized over I2C really helps. It's a lot faster if your I2C bus is faster. I think the challenge is that if your I2C bus is exposed on your board to other things, then you risk kind of confusing it. Although when talking with Lamore about it, she said that if an I2C device can't hear its address when it's too fast, it just won't do anything, and that'll be okay too. So I guess I would say it's probably okay. We can see, but generally you want APIs to work the same as well. And in that case, it wouldn't work the same if different boards had different speeds by default. But if speed actually matters, I think you should be explicit about it. If it has onboard devices, it makes sense, but it needs to be reinitializable at lower speeds per device if user needs. Yeah. Unexpected Maker, do you have any H2 or C6 stuff coming? I don't even know. I was looking up your tiny S3 stuff a little bit. S3. S3 is a good chip, I'll tell you that. Neat. All right. Let's go back to the PR. Well, it should be pretty quick here. Oh, we were trying the H2 to see if we could turn BLE on. Yeah, see, so it has, I must have put it wrong. It has 806K free or something. I have a tiny C6, but not in production, as Arduino, MicroPython, and CircuitPython haven't dropped yet. Well, you could add it to CircuitPython once this PR is in. H2 is not very compelling. Yeah, I get that. I understand that, but I have it, and I thought I'd do it just in case people wanted it. It really wasn't too hard to support, but it's very minimal support. Okay, so let's fix this. I must have like meant to put it on a different board. I assume it works. Maybe not. Maybe I'll have to fix it. You know, I'll probably do a clean. So here's an example of a QSTR error that happens because I changed what was included without cleaning. So these are like all USB. It doesn't know the BLE related QSTRs because like it wasn't smart enough to know to rerun the QString process. So if we clean and make again, it might fail, but fail in a different way. C6 is interesting because it has Wi-Fi 6 support and it has more RAM. I don't actually run like network test stuff, but be curious to see if it's like more reliable for folks in terms of like, I think Wi-Fi 6 is supposed to be better about handling congestion. So yeah, I think Unexpected Maker is right. Like we'll probably see more C6 kind of dev boards than we will see H2 dev boards. And one of the things that H2 is meant for is like matter and thread support, which we don't have in CircuitPython. And correct, Johnny, H2 does not have Wi-Fi. It's BLE and it's like thread and matter, but it's not Wi-Fi. 6's loads better. Is it also the device sleeping that you get like for matter? I don't know what you mean by that. Yeah, so we got plenty of space and it compiles just fine with BLE. I don't know why it was off. That's just a mistake. And I'll push it to the here because I haven't done the review yet. Maybe I saw the 4 megabyte and thought I needed it, but I don't. Unexpected Maker says, and Wi-Fi 6 takes less power apparently, so hopefully it's better for connected battery projects. Yeah, I haven't done any power testing whatsoever. One thing that's interesting about the H2 is that there's this huge gap between 12 and 22. And it's that's where the QSPI pins are. They don't even like tell you anymore, kind of. But CircuitPython just like blanket resets pins, so CircuitPython has to have a thing that says like, oh yeah, and don't touch these pins. Otherwise it times out like that bug that we've been seeing. Like the watchdog goes off because you hose your flash. What is Matter? Matter is an IoT protocol thing. It's meant to be, it's this thing, build with Matter. It's meant to be the end-all be-all of IoT protocols. The promise of reliable and secure connectivity with their stock photos. It's meant to be like really good for provisioning. But the reality is that I don't know, like the Hue just updated to it, but it's still pretty early in terms of like adoption. So I'm not sure what like CircuitPython supporting Matter would actually buy us. Eric asks, you mentioned something called QSTR. What is that? So I don't know what it stands for. I think there's a link. This is something that we inherit from MicroPython. And what it is it's string interning. So it's kind of like the regular C compiler where if you have multiple copies of the same string, it gets deduplicated, and then it gets assigned an ID. So in the source, you'll see this like MP for MicroPython, QString, and then after it is the name, is the string itself. And there is some like post-processing that happens about like periods and things like that. There's a file you can find about it. But there's basically in the build process, and this is true for MicroPython and CircuitPython, there's a first prepass to figure all of the Q strings that occur in all of the source files. So it does pre-processing, and then it greps basically all of the preprocessed source files for the NP Qster. And then it assigns numbers to them. It creates macros that replace this with a number. So the storage here is 16 bits, so it's 2 bytes. And then there's a separate tree lookup. I found this too, so it's weird. It's here. I was looking here and here and here, but it's actually this big thing here. Is to their technical documents. It took me way too long to figure that out as well, which is, yeah. Like I said, like, yeah, it makes it kind of hard. But it's actually, yeah, it's on the left here. It is there, it's just like not in the regular pattern of all the other stuff. So Q strings are deduplicated strings. So the identifiers in the source code get replaced with a number via a preprocessor macro for the second stage of preprocessing, and then it builds a separate lookup table that maps those numbers to the actual strings, and caching, and not caching, and hashes for them as well. So when strings come in Python code, they do get looked up against the existing number of Q strings, and if they're found, then they'll just use that number instead of storing the string itself. So it's kind of like a souped up version of string interning that the compiler does. Hi FedA2. David asks, what kind of Wi-Fi do you have at your new place? Do you use the provided router, or you have your own Wi-Fi for better control? So I have separate internet from the other folks in the building. It is fiber. It's very similar. It's basically the same fiber that I have at home. But I am currently using the ISP provided router that has Wi-Fi on it. I was thinking about switching to the Ubiquiti, not the Dream Machine, but their newer one, Dream Router, I think, which I think does have Wi-Fi 6. But the problem is that even on the website, they say that the WAN speed is only 700 megabits per second, whereas my internet connection should also be able to do it should be able to do up to 940. And if I do a speed test, I don't know what it will do with a stream, but I can get over 700 on the speed test. I don't know if it'll show my IP, but I don't think it matters. Yeah, so that's the thing, is this provided router, it doesn't have as good a Wi-Fi. It's Wi-Fi 4 or 5, it's not Wi-Fi 6. But the WAN access speed is really good. So this computer is plugged into it, and so I'm getting 900 up and down, which is kind of as good as it's gonna get. So I'm really happy about that. It's great for uploading YouTube videos later. Oh, and this shouldn't be there as well. This should be a global setting. I messed this up. Secondary USB serial JTAG. That should really be in target settings. So there's this new target that I added. Update. I see your question on Expected Maker. I'll get it to it in just a sec. Update all SDK configs. So this will take it and split it across all of the files. And what I wanted, and it didn't do it, is I wanted it to, so this change we did and we want that. Oh, see, now it deleted it. Okay, so that's what we want as well. It must be in there, it's just not right. This is the 48. Oh, it switched it to 64. I wonder what that is. It's not right. Oh, okay, so it put it in ops. That's a fine place to put it. So we'll do that too. Yeah, lobbying for fiber was my thing. I mean, yeah, there's lots of places that don't have fiber still. Okay, so Unexpected Maker says, oh, also the C6 has BLE 5.3 support. Oh, and it's the first ESP with BLE 5 audio streaming ability. So how's BLE support in CircuitPython going? We haven't, I haven't worked on it at all, so it's still like in this like partial state of, the problem is still that we don't have the dynamic service creation after a connection is made. Nimble's probably changed a lot with the IDF 5 update because espressif does keep their own version of Nimble, but yeah, I'm not sure. I'm not sure where we're at. We haven't looked at it. I've been really pushing people to just be like NRFs are great. NRFs are great for BLE. Especially the Pico people. The people that want the Pico W to do everything, it's just like, it's complex. There are simpler options that already work for the same price or similar price. Unexpected Maker says, I have a Dream Router at home and a Dream Machine SE at work. Dream Router has issues when updating firmware, but otherwise working great. Can you, are you hitting the cap of the WAN upload speed? Because that was the one reason I was like, But I do have I have Ubiquity at home, and I really do like the administration from a central place. But I'm not about to pay them, a subscription fee. Okay, so we found some changes that we want to make, and that's fine. So let's keep going, and we'll push something else. It hasn't been reviewed yet. This is a board that just came in, and we had to update it. I wasn't sure about the console UART stuff, so I left it. NRF boards don't have Wi-Fi. You're right, they don't. What uses do you see of having BLE and Wi-Fi at the same time? Oh, no QD NRF. Project on hold waiting for ESP Bluetooth. Well, if anybody wants to give it a shot, I'm happy to brain dump. I almost did pick it up again, because I think I know how to do it. We have slow internet in backward Australia. Dumb politicians telling us we don't need fast internet. I hate that. Drives me up the wall. I really think I spent a lot of time thinking about this, and I really do think that this speed, this gigabit symmetric, is really the sweet spot. And the reason is that a gigabit Ethernet is so universal. Anything above gigabit Ethernet, and then you get into higher tech Ethernet gear, maybe 2.5 gigs, because I'm seeing that on more desktop motherboards, but really at the moment, gigabit Ethernet, and that's what your internet should match. It's a huge mind shift when your connection to the internet is the same as your computers at your home. So yeah, I'm sorry. Fast internet's awesome, and everybody should have it. And all of these companies that want to like piecemeal you every 5 years to get higher speeds just need to give it up and realize that that's not the world. Fiber is a much better investment. All right, we're going through files. This is good. I don't always review my own pull requests, but apparently when I do, I find changes to make. Beely-based device detection to auto-connect Wi-Fi type stuff is very handy. But yes, 99% of the time, you don't need Wi-Fi and Beely together. Yeah, and our assumption is like you got to get CircuitPython on the device, and so we might as well get Wi-Fi credentials then too. ESP32, like there was more stuff in fast RTC memory or something. So I did have to reduce the amount of sleep memory we give to the user. I just didn't want to have to bother with it. This is a... Oh, if ESP Deep Sleep Start can actually return now. And what do we do when it returns? I'm just hard fault. I'm doing a safe mode when it fails. I only have 100/50 here and pay through the nose for it, so no 700 cap issues. Yeah, I'm paying $65 US a month for gigabit symmetric. It's awesome. I pay 85 at home because I bought it ages ago and I'm on like a will never change your price plan. They reduced it. But we'll see. I don't know if I've gotten billed yet for it, but I think like taxes might make it higher than the 65. Mark says, I always love when I find out my home connection is faster than the server connection I'm connected to. Yeah, that is an issue, right? I mean, I'm in urban Seattle, basically. It makes sense for them to have pretty good internet service here. Okay, so this is more target specific stuff. There's only one ADC peripheral, so I had to like change this code. On the C6, there's only one ADC unit, not two. So this code that's designed for 2 units, I had to change a little bit. And I'm really biasing myself towards these sock underscore macros because they're kind of what the whole IDF uses to know kind of the settings for a particular sock, like system on chip. So they're really like, they're much preferable to these like per target things because there's like there's files for each of the targets that has all these sock definitions, which is really nice. So like that'll hopefully make it easier when we add P4 support. If we're using sock definitions, it should just work, ideally. Analog in, I changed because the C6 ADC is not supported by the legacy driver, so I just updated it. And as I admitted earlier, I didn't actually test it. So that's one thing folks can do if they want to help. Ooh. 100 symmetric for 45 a month is good. I think that is like, yeah, the thing here is like, most of the alternatives people have is it's going to be like Comcast, the cable provider, has gigabit internet, which is actually 35 up. It's like a gig down, but 35 up, which, you know, when I need to upload a big file, I really appreciate being able to upload it quickly. Analog out, I updated it as well. I don't remember exactly why I did, but I did it. So I really should test that. I'm not a great tester. It's one of those things I should be better about. And talking about people that like really shaped CircuitPython, like Jerry N, who you know on Discord, he's a really good tester. And I remember telling him one time, I was like, if you ever find an issue, let me know, because I'm not a great tester. I'm happy to fix it, but I'm not super thorough. Lamore is also really thorough. I'm not. This is unfortunate. So there are some if they have one CAN peripheral, which is what this is, they'll either call it TWAI 0 or they'll call it regular or no 0. Hi, Mayer Makes. And unfortunately, these two symbols, the TWAI and the TWAI 0, they're provided by the linker script, which means I can't say if it's defined, then do this other thing. I tried that and it didn't work, which is why I'm telling you, like, we just got to do it based on target, and it kind of sucks. This is a fix, and it has this like IDF issue link, and it's just incorporated because we updated. So we no longer need to carry our own version that's fixed. More header stuff. Different numbers of timer groups. I'm a 10,000% not a good tester of my own stuff. Kicks my butt so often. Yeah. Meyer. Okay. Hey, Clem. Mark says, I'm with you there. Thorough testing is hard to do. It gets worse the more I have been working on something too. Yeah. Yeah. That's why I like strict compile flags, because it forces me to fix them. GPio 24 just wasn't listed, but we actually need it now. I switched it to using this sock pin account instead of weird target-based rules. And then these are the never reset. So these are the SPI pins for the C6, the serial JTAG pins of the default UART, and then for the H2, flash pins, some pins that they don't make available, but I'm not sure what they're used for, serial JTAG, and the UART. The C6, I think, has the ability to actually hold a single I/O without having to turn it on, which should be better for power. So I'll be curious about that. And this deep sleep, hold, enable, and disable, those functions disappear if they're not supported, which is kind of unfortunate. So that's why we have to protect them. If this was CircuitPython land, we'd still have the functions, they just wouldn't do anything, so that you could call them. Yanni says, Fede2, any cool new riscV boards? So the H2 and the C6 are both riscV boards. Just saying. You want riscV boards? Those two are both riscV boards. I think, like we were talking about last week. CPU frequency, they switched it to a single setting instead of per target. This is the unique ID from the MAC address register, and only the H2 has it different. This is the RTC LP Aeon, and I could probably redo this, but because the target is in the path, I chose not to. So this is where we store our safe mode register and how we set it to go into the bootloader. It's there. ESP camera I updated so that it builds correctly on C6s. Basically, it doesn't build, but it doesn't crash because it knows it shouldn't. Here's the IDF update to the 5.1 branch for us. With 5.0, I removed all the default settings that were set to defaults, and that's why debug is a lot thinner, is because the default settings are now not included. I meant to do it in 5.0, but stuff I meant to do in 5.0 I just did here. This Wi-Fi settings have moved around a little bit. They renamed a couple settings in 5.1. Here's the new defaults for the C6. So these are target-specific defaults. You can see extended advertising's enabled, and BLE is here. I had split BLE off before, but I'm kind of moving away from that because some of the BLE settings are target dependent anyway. So here's H2, S2, S3, more, oh, there is a 64. More flash frequency tiers. The error message told me I could only do 48 on the H1, but I bet it's actually 64. Added a new 48 target, which it seems it's not actually using. added, so these flash files do include non-defaults so that they're uniform. I can change that. Yeah, turning on experimental features, that'll allow us to do 120, which I think it is worth doing on the stream because it's something that we're gonna need folks to do on other boards. Like it's 100, we have 130 or so boards, ESP boards, and so I don't own them all, and so we'll want to test them. Here's the libm switch. Here's some default settings for C6, and like I said, oh, RGB Matrix is off for H2, but it is on for C6, maybe. We'll have to look at that. And serial JTAG is off by default on the S2 and 3. Getting there. MP HAL port. This is when we do the garbage collection, we have to know where to look for root pointers, and on extensa, and which actually we should probably say explicitly extensa here instead of not arch. But you have to get them out of like this register thing. You actually gotta get them written in memory. Here's the C6 pins. It's got 31, so 0 through 30. Indices, it's got one ADC unit, blah, blah, blah. And here's just the declarations for it. H2 pins, it has even fewer pins. It's just got through 27. But there's a huge gap where the pins are for the SPI flash. The only chips that they sell right now for H2 include in-package flash, either 2 or 4 megabyte in-package flash. Here's the pin header. Adding this redirect there. Here's the low power RTC add-on stuff again. So this is this, I was gonna say saved word, but it looks like it might be, yeah, it is the saved word stuff. Previous one was resetting in the bootloader. Build memory info, this is what checks to make sure that we're not running out of space. So you put like the different memory maps in there, and that's what produces the kind of report at the end of the build. Although it didn't do it there. Maybe because it was the same. Milk 5 stuff this week, but I haven't played with it yet. The Duo, which is dual core, 1 gig and 700 meg microcontroller that runs Linux with 64 megs of RAM. Mars, which is kind of like a slower board to a Pi 4. Got a donation of a Pine 64 tablet, and the software is getting better by the week. Riscv is certainly the future, I'll give you that. And then I made a few changes to this update SDK config script to actually detect whether BLE is used in the target. And this makes it just easier to fix it up. Oh, let me tell you, I don't like kconfig. I had previously had this like item.reference. So this is like the, if you have an item in kconfig, what does the default value depend on? And all of the menus and stuff. And that was really great because I could say like, does it depend on BLE? Does it depend on SPI-RAM? And like filter, send it different ways, like different files to have it. But I found a case where the settings in kconfig can set other values. Kind of, like configuration languages should be simple. This is not simple. But basically, like setting a value on one can override the value of another, and the other one doesn't know that the first one can do that through this referenced property. So I added this ability that it does have reverse dependency, so it knows the things that could set it, and so it takes all of the things that thing references, and maybe it should do it recursively. It's stupid. It is a complicated configuration system. But yeah, so there was like some SPI-RAM dependent thing that didn't know it was SPI-RAM dependent, or Wi-Fi dependent, something like that. Here's the new ESP serial stuff. Here's, I was complaining about this, I think, the QString process, if the header preprocessing fails, it fails with like the big long output of the command it ran. And so I stopped having it do check, and instead I checked it myself, and then I raise a like smaller error message. Then lastly, here we have this CI check that makes sure that we don't reuse USB PIDs. It also works for creator IDs, which are my creation to have some like names, numeric space for identifying boards or whatever. I was also thinking ahead to like FPGA land where you needed to know what a peripheral was. But it has this regex to detect whether it should be USB or not. And so I added C6 and H2 there as well. So C2 won't work. There's some work more there, but if I happen to have some stuff, then I would do that. So yeah, that's that. Let's commit and push. Yeah, so this report here is what is generated by that RAM layout. So this LP SRAM and HP SRAM numbers, well, all three of these lines come from that script, and then these are the target specific things. So let me finish this. So these are already added, which is great. So let's just say enable BLE on H2 devkit. It's the only devkit that has it, so it's basically all of them. And we'll push that to our branch, and it'll show up on the pull request. Love the Factory asks, which one is best for internet? With on-chip Ethernet Mac instead of slow SPI alternatives. Are you talking? You're probably not asking me. You're asking FedA2 about the Milk 5. I don't know a lot about Ethernet, so I can't. I've not actually done Ethernet myself. Okay, you know what? I got more boxes. You probably can't see. But the I have these like higher. I'll just do it. Trying to loosen my camera without like completely jarring it. Yeah, so I have these two more IKEA bookshelves. These are like new calyxes, and you can see I got boxes there and some blank boxes there. So I've been, as I try to find things, I've been like, okay, I'm gonna spend some time separating stuff out. So I think what I'm gonna do is I'm actually gonna, I think I have my S3 box here. And I think I added some of the Adafruit boards to it. Nope, I didn't. Where did I put those? I thought I found S3 feathers. This is the problem. Maybe we'll just do a QTPy first, because that's what I have. Oh, you know what? Here's a Feather TFT ESP32S3, and it's a N4R2 S3 Mini. So if we pull it up, if we pull up the board settings here, This is the S3 Adafruit Feather S3, not the reverse, but the regular TFT. We'll see here it's set at 80, which is probably actually good. These are set at 80. Well, I'm looking at this number here. 80, 80, 40 and 80 for this S3 4.2, which actually is, this one's 4.2 as well. Do we have two versions of it? We might. S3 4.2, this one is also 4.2. So I'm just gonna change this. Like, it's probably the same module. And the module is really the thing that's gonna dictate how fast it runs. Let's just take a look, because there is this, yeah, so it prompted me to refresh because it had the changed files. Let's just find this 120 megahertz flash setting and see what it says about it. ESP PSRAM. It's only the S3 that can do it. See, there's P4 in here because I'm looking at master. SpyRAM mode, type, speed. Quad PSRAM at 120 is stable. Octal PSRAM 120 is experimental. It works when the temperature is stable. Which is probably fine for us. ESP PSRAM. Where's the flash settings? NVS flash, SPY flash. So S3. So this sock caps in is like silly. Config. Dangerous right. Where's flash speed? So this gets interpreted via ESP IDF config. And the speeds. Oh yeah, ESP tool flash frequency. That makes so much sense. Great name. I think it does apply to the actual startup speed though. So yeah, so see here we have, there's this component SPY flash ESP flash SPY init, and it just maps from ESP tool flash frequency into this default flash speed, which is just like, head desk clipper, the make clean of calibrations. C2 is default to 60. HPM is high performance. Yeah, see, like 80 is usually what I see here. Like here's a S2 default at 80. These are like the settings they did for like the performance test. So I think 80 is like pretty safe, actually. Like the chips themselves or the die should be able to do up to 120. Anyway, let me just take a quick peek at all of the board configs for 8 different boards. Boards. Yeah, so this is DIO. This is a Feather ESP32V2, which I know I have. Do I have it on my desk? I do not. But like this sort of thing should be able to do QIO at 80, I think. Here's another DIO at 40. That's the Feather S2. S2, DIO, DIO. Just bump that one up. S3 reverse TFTs at DIO but 80. So yeah, I think a lot of these are clocked too low. Well, they work just fine. They just don't work as fast as they could. If they were clocked faster, they'd run faster. That's not entirely true, but I think it's pretty true. Because this is a matter of, like there's a cache in front of the flash. So if you hit the cache, you're fine and it's fast. But anytime you miss the cache, like you're gonna be twice as slow as you need to be, or more. So that's kind of what you're speeding up, is the times that you miss the cache is when you're speeding up. And like CircuitPython, because the VM's like not small, my guess is that you go through that RAM you go through that cache pretty often. I did some optimization work on the IMX to make sure that the VM could run all on its own without the cache, or like using the tightly coupled memory instead. Okay, I know I said I was going to do that, but I don't really want to take my mic off and have to get stuff out. Let me just look at the cutie pies, because it looks like I have some cutie pies here. This is a cutie pie ESP32. This is a cutie pie 2040. This is a cutie pie ESP32 again. It's not really the one I want to optimize, but because I don't think they can't do the 120, which is the more interesting piece. So I don't know. I kind of want to do this matrix portal stuff. Any objections to doing matrix portal work? I doubt it. Doubt it. Let's just shift this. So actually, let me show you what I'm doing. Here's the overhead, and it's not in focus. That's better. It's upside down. There we go. So this is the new, this is a Rev B, but Rev C will be, I know Lamar did a Rev C. So this is a Qualia board is the like trademark name that I think they're going to use for it. It's like a TFT testbed sort of thing. It's kind of like a matrix portal, but for these like fancier TFT parallel displays. I showed this one earlier as well. But this is the one that takes the initialization that I don't really want to work on right now. I kind of want to do this matrix portal stuff because I think it might be easy to fix. And it's Friday afternoon, that's what I'm looking for. So I'll just take this off. So this is the like PC byte probe system where they have these like, these are like spring loaded a little bit so that they set really well. And I did get one as well that is, so I was using that to read the UART because I'm lazy. I was just like had it on the UART pins here. But you could use it for other signals that aren't just pin headers. And then these are the holders. These are the holders, and this is spring loaded. So the yellow bit is to isolate from the metal, and then you can put the board between that. That moon calendar was just stunning. Oh, is that a matrix portal thing? Moon calendar? I missed it. Okay, so got here is, so this is a matrix portal S3, and you can see I've gone a little crazy with my label maker, especially for all of these modules. I've labeled the module so it's easier to read instead of squinting on these like things, because I've been doing so much ESP work. I did that. And then I'll only show half this matrix because I think the matrix portal itself is probably the more interesting piece. At least that's what I'm going to be loading at. So let's see if we can get RGB Matrix working in the next half hour on this. I don't know the current state or anything, but the first thing I'm going to do is I'm just going to work off that 5.1 branch, because if like I don't get review feedback from Dan, over the weekend or before I fix this, like I'll just push there, because it's all 5.0 related, even though there's an issue for it, a separate issue for it. But once the review starts, I'll not do it. But before that, I feel free to do it. Okay, so this is just this is like fresh out of the box, fresh from Adafruit demo. So it's really nice because I know that like the display works and my setup works for it, which is great. So I'm just going to reset into the bootloader. I'm not even going to, like, they warned that UF2's not in it. I'm not even going to use the UF2 bootloader because my dev workflow just doesn't include it. So let's do this. And sorry you can't see me, but that's the nature of it. So we're going to make board equals Adafruit matrix portal S3. And we might as well put the port because it should be active. Dev serial by ID USB, and we want this serial to JTAG thing that the bootloader uses. I'm gonna clean and then I'm gonna build. Let's do a quick take a look at our defines though, because ideally it should be enabled, but like there's no reason for us to start working on this if it's not turned on. So there's nothing here that's disabling it. Matrix portal S3. so let's take a look at the top level. So right now I'm just making sure that the RGB matrix stuff is being compiled in, which in theory it's not. Although it kind of looks like it is. RGB matrix. Ah, see, there's this disable temporarily. So let's set that to 1. And we'll delete that. And let's see where we're at. We did the clean already. I need a moon calendar. Ari, my kiddo, loves to look at the moon. I made the mistake of asking him if he wanted to go see the moon on a day where it was cloudy. I was like, oops. Can't see the moon when it's cloudy. Or when it's like a new moon. I've come to appreciate that more than I have in a long time. All right, so we're starting to build. Let's see how far we got. I guess while I'm doing this and I'm not loading it on the device, I could show me. Anybody have weekend plans? I don't think we have much. I'll probably go home and play a little video games, though, so I think the kiddo will be home a little late. So I'll have a little bit of time, I think. Should I find the moon calendar? The Philby project. Oh, phases the moon from an API and shows them on the round screen. Nice. Yeah, these displays are nice. I am interested in doing it, and I made this like test bitmap, and I kind of want to have a test bitmap for round displays that will has concentric rings for like how big it is. Nice. Phases of the moon. That's what I need. I also want like moonrise, moonset times, because he goes to bed at like 7:30. So gotta know. Okay, so static declaration of PM start timer start follows non-static declaration. Okay. Why is that? That seems weird. So we are in. So I wouldn't be surprised if we had, so RGB Matrix support uses the protomatter library under the hood, which is a library that we share with Arduino, actually. That Phil B is the main person who does it. So I wonder if the simplest thing is PM, was it timer start? Arch 32, 130. This could be if we're compiling for CircuitPython. And we're IDF major version 5. That would explain it. So I saw this and was like, oh, that seems familiar. And I looked, do I have this open still? Basically, yeah, this is the thing I found earlier. Like microdev already did work to support ESP5 in protomatter. Like he's the one that told me he disabled it. So maybe it doesn't work. But like, just like the 5.0 update, like microdev got it 90% of the way there, and I just had to do the last 10%, which is non-trivial, but like it's still hugely helpful. Hey, it compiled. Does it work? flash it. So we're gonna need some test code. And have I done RGB Matrix stuff before? No. It's been a minute. So here's the Protomatter guide. Oh, look at that, 105. Here's the basics. Does the basics? No, the basics does not have CircuitPython on it. Looks like Jeff's guide is the place to go. Oh! Why did my tab crash? Test example code, that's what I want. The library works with a limited number of boards. So this is not test CircuitPython code. This must be mirrored, probably. This is probably like to make sure that, what am I in? Did I click the wrong thing? I'm in the basics guide. I want the CircuitPython guide. It crashes my browser. Oh, no, it's back. Connecting, using a matrix portal. Let's do Game of Life. Hopefully it's not too complicated. I mean, it's a little complicated, but hey, look. Download project bundle. Open it up. Nice. You're gonna go see folks play. Hi, Electrofix Labs. Percussion Festival. That sounds cool. Darn. Oh, wait. It's just a code.py. Let me hit reset. Should pop up. There we go. And it's got hello world on it. So since it's just a code.py, we can just copy it here. Hit copy code and save it. And we got an exception. Okay. Matrix portal. Module object has no attribute D6. So it must be all right. RGB pins. Do we have better names for these? I bet we do. I could look at board. Maybe I should just look at board. 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 I don't use the REPL for that many things. Okay, so there is so there's matrix adder A, B, C, and D, E. Matrix address. What is matrix address? matrix common. Ooh, that looks familiar. So RGB clock latch. Okay, so we can do address pins, board.mtx adder, and then we can do board.matrix common, and the 2 stars unpack it. So it's like each keyword is in, and its address. Uh-oh. We crashed. We crashed hard. This is great, actually. This is something people ask about. Okay, so I have an ESP32S3, and I crashed. It's telling me hard fault, memory access, or instruction error. That's no good. How do I figure out what's happened? So let me go to the overhead. I saw that ZKM, like K&K but with Zephyr, uses something like Aeon. On the next boot, go to UF2 for updates. You can reset the board by using a keyboard button instead of PCB button. That was pretty cool. ZMK. Okay, so it's like C code that uses Zephyr rather than whatever QMK uses. I have my own bespoke keyboard stuff that works just fine in CircuitPython. Okay, so what I'm going to do is I'm going to do a debug build. So I'm going to clean, and then I'm going to do a debug equals 1 flash, and I'm going to go over here and reset. And let's go to the overhead. So sorry, it's a little washed out. So now what I'm going to do is I'm going to take my things here. I have them connected into, this green one is connected into the RX of a serial converter. So I think I'm going to put it, I think that's what debug is here, is the TX debug. So I'm just going to, you know what, I should use a holder. Raise it up. I don't think these holders can actually completely hold the matrix, but it's okay. And then that, and then the green one will go on debug, which I think is the debug output. And this black one is ground. And they say 45 degrees. So now, if I just reach around and do the boot again, hopefully we'll, yeah, so we get the boot output. Oh, yeah, so here this last bit tells us that our debug output is now working, and it's waiting for the flash to happen. And there goes the flash. We'll have to hit reset. I needed Unicode, so I went with ZMK. I plan on going to CircuitPython as soon as possible. I should say that my keyboard library I'm using, it parses the QMK layout files, like the JSON files, to know what buttons are what, which is kind of neat. But I didn't want something super heavyweight, like the MK things are. Okay, so let's hit reset and we'll see where this crash happens. Okay, so when it's in debug mode, it has this, instead of resetting into safe mode, it will, if it's working right, it will go into the panic handler and then stop. So this is the thing that the IDF gives us for when bad things happen. And it gives us this backtrace. So what we can do is we can copy the backtrace. And there's a Python tools. So this is in the espressif port, decode backtrace. And then you give it the board. So it's Adafruit matrix portal. Because it loads, it uses the board to load the S3 or the S3 file. Okay, so we're in run code.py, clean up after VM, reset displays, de-init, de-init1, timer disable. So we're in RGB Matrix 63. And what's probably happening is we never initialized correctly. What we think we did, maybe. So let's do ports, common HAL. Actually, no, this is not common HAL. Oh, no, it is. Common HAL, RGB Matrix, RGB Matrix. Common HAL, RGB Matrix, RGB Matrix, and enable, disable, free. We're in disable line 63. Okay, so we're right here. So the only reference we're doing here is this. So I wonder if this is what we need to check. So it's trying to check the timer index and then shut it down if need be. But maybe there's a world where we never allocated a timer or it didn't work. And so we freed it, but it didn't check. So the other thing I like to do is I'm a printf debugger mostly. So let's start adding some printfs as well. Const char. This is a standard thing. The tag for CP or RGB Matrix for logging. So I'm just going to say so here's a malloc call, but I wonder if this malloc call is failing. ESP log info tag timer allocate, and we'll do the pointer that we get. And let's do similar timer enable and disable. This will just give us a better idea what has happened before we get to this point where it's not working. So we don't need the backtrace thing, and we only changed CircuitPython code, so we don't need to clean. And let's put it back in the bootloader. So we're flashing again. If folks have any other questions, now's a great time because we've got about 15 minutes left before I stop the stream. My camera's a little high, I think. What do folks think in terms of angle of this camera? I kind of like that you can see some of the boxes, but maybe not all of them. And I guess this is zoomed in mode too. that should be better for focus. All right, let's reset and go again. It's all about the boxes. I can't tell you, it's pretty unreasonable how excited I am about these boxes. I've made 2 orders and I got the second order and I've got, you know, like just under 10 blank boxes, and I'm like already thinking I should just do another order. It's like $60 an order. I got 28 boxes last time. And I was like, how many more squares do I have? Like I've got 4 cubes of the things that are empty. And I haven't gone through my FPGA boards or my other microcontroller boards yet. And it takes like a week and a half for the boxes to get here. So I think I'll probably just order more. They're not too bad. Oh, sweet. So it didn't crash. Or at least it didn't hard crash. I'm looking for the blink. It's still blinking like an exception happened. Redoing my workshop these weeks, and it's such a great idea. Yeah, I don't know why I'm excited about it. Okay, so it reserves 0 bytes. I wonder, did we even run? I don't see any of those logs that we just added. So I wonder if, well, let's see what this says. It's in use. NTX R1 is in use. Oh, you know what? I bet it's a JTAG. Did the logs go to the other UART? No, they didn't. I don't think we got there. When you do a debug build, I mean, it seems like we're... You know what? I did fix the issue, right? I added that null check. And I put the log after the null check. So let's actually move that up there. And then the other thing that's been hampering me is that there's this code in port where if you do a debug build, it doesn't touch the JTAG pins. But the JTAG pins aren't on by default, and I was meaning to add a check to say, like, is it actually possible that these pins are used? But in the meantime, I'm just adding an and false here, so it just doesn't do that. And we don't have the file system mounted, so let's do a new build. Maybe there's some place that's just calling that one null and not being smart about it. Yeah, timer is undeclared. I know. I moved it and I didn't change it. So now we'll know if something's calling it with null. It's possible. Seems like it's not getting null from the allocate though. It's not getting that far. Seems like we fixed that crash though. This will tell us for sure. Okay. Reset to get out of the bootloader. Back to TO. 5 address pins, 6 RGB pins, and 1 tiles indicate a height of 64, not 32. I don't even know what this panel is. But I feel like it should allow me, it should be okay if I gave it too many pins. Maybe it should only error if it gave me not enough. But we could also just change it and see. Here's our timer disable call. And in fact, we had a backtrace for it, didn't we? Like, should it really be calling or at main cleanup after VM reset displays? maybe that's what should be guarding the de-init. Shared module display IO in it. Like, it really shouldn't try to de-init it if it's null. It should be smarter than that. $227. I'm surprised that the address of PM base. So it did get the typeset, but the object itself is null. Any display uses this frame buffer. It's the address of the base of the object. This really shouldn't be null. So I don't, if timer free, this could be a problem with RGB Matrix. Like the object got allocated somewhat, it's partially allocated. de-init 1. So this self-timer is the problem. So we should say if self-timer is not null. So I'll leave the guard in the other place as well. It's fine. Comparing event 0 is pretty easy, but I'll do that as well. So we stop doing that. The other week we talked about manual backtraces, but there were other issues. Would it help here? I don't think I need to know, because I feel like I don't need another backtrace because it works. I kind of know where I am right now. Fede2 says, how's the Sony camera working out? I'm thinking of buying an A6100 for use with my Venus macro lens. I've been with Nikon most of my life, so I'm a bit hesitant to do this. This Sony video blogging one has been great, but I've also only used it in this context. It's not been used for anything else, so it's fine. But I haven't used any of the other Sony stuff. I just was looking at an article. They like released a new version of this that's like $2,200. I was like, it's for like video blogging where you're like out and about as well, not just as this like webcam setup. But I'm pretty happy with this. Just like I was thinking about this, just like my like gigabit internet idea is the sweet spot. I think that 1080p is the streaming sweet spot for me as well. Like, you're getting one-to-one of the pixels on my screen already. So if I wanted to do 4K, like my screen would need to be 4K as well. And I really like ultra wides, and they don't, as far as I know, they don't have like 4K tall ultra wides or whatever they are. Like they don't have those yet. So yeah, it's been working out fine. Okay, so this, let's just try to figure out what panel I have. I'm in the middle of something, so I'm gonna keep going. I have, this panel's pretty small, and my guess is it's 32 by 64. I think it's this one. 64 by 32. Let me use my hands for size. You can't see, but I think my hands, that's pretty similar. Yeah, and you can see that I purchased it October 23rd, 2020. So it's 32 by 64. So let's open up our code. And do 32 by 64. And it's still complaining that 5 address pins, 6 RGB pins, and 1 tile indicate a height of 64, not 32. So do I just strip an address pin? So I do a slice, maybe? Hey! Oh my goodness. It works! I'm not sure if the orientation is correct. But this looks like what I would expect for... Oh, and we saw the REPL here. Oh, it doesn't look right REPL-wise. That's not readable. So if we're looking at Blinka here, like this should be Blinka in the corner, and then we should start to see the start of the title bar, so like Wi-Fi. So our pin names our address lines are wrong, so I wonder if we just do that. So that I don't know what they're supposed to look like. For 2 generations, and then after 2 to the n generations, fill the board with random values. So here, it looks like we're just not addressing some of the panel at all. So to me, it looks like it's working. It's just not working correctly. And I don't know enough about these. See, it says it requires 6 bits of data, 7 bits of control, and a good 5-volt supply. So we have the 6 bits of data, but I don't know. I wonder where we could find like the right settings. I just don't have like the right pin settings. Upper RGB data. Over to the bottom half of this display. And the other place we can look is, like, there's the matrix portal library. Sorry, we'll wrap up here in just a sec, but this is like, I'm so close. So close. Oh, and you can't see my Yeah, sorry, I'm looking on Learn. Let me go desktop and overhead. So I was looking at the basics LED matrix guide, and now I'm looking for the matrix portal code, which hopefully has, like, it has the simple tests. It's 64 by 32. Matrix portal board is ABC. If height is greater than 16, then add D. Okay, so that's what we did. And then the RGB pins are R1, G1, B1, R2, G2, B2. Is that what we have? Or dot. Maybe these are wrong. R1, G1, B1, R2, G2, B2. Clock, latch, output enable. So those are right. But this is not. What's the magic permutation? So I did this right, where I wanted A, B, and C. R2, D2. Beep, boop, boop, beep, boop, boop. This could be a problem with the code itself. I doubt it. You know what I could do? Final thing. Oh, it's so annoying though. Oh, you know what? I have a branch. I have CircuitPython 8 branch, where I can make board Adafruit matrix portal S3 clean. Let's just see if it works here. Then I know my code's right and the behavior is wrong. All right, last thing we're gonna do, we'll load A2 on it and then be done. Ask ChatGPT. Could it be the unpacking? I don't think so. I don't think so. The star unpacking should just take every key in the dictionary and make it like a keyword arg. But it shouldn't change like the order or anything. It seems right. It's close. Oh, and you know the test demo worked too. So it could be just a protomatter bug because we were looking in protomatter and there's this like it's updating. This IDF 5 thing. Hold on. I had to sneeze. So here's IDF timer, start, stop. This stuff is all pretty straightforward. Like the pin numbering is going to be the same. That won't have changed. All right, still flashing. I'll just take the weekend and let my mind think about it all weekend, and then I'll be like, oh, that's probably what it is. I did that twice. So like the C6 was crashing, and then I realized I had to do the like architecture flag, and that worked, and it fixed it. And then with the H2, it wasn't working, it was crashing, and then I was like, oh, I bet it's the flash pin protection thing. That's what it was. So taking a break is very valuable. So let's just see if it works with A2X-ish. It's A2X-ish, it's my own branch, but let's see what it does. See, that doesn't look right either. Well, this time it's blue. Does it pick a random color? Yes. Whew. Okay. It picks a random color. It isn't. Oh, you know what? This address thing is not right. Oh, I crashed it. I wonder if this is the same bug. Anyway, we're over time. Obviously, is Blinka blue now? I bet the crash that just happened is the same crash we already fixed, which is maybe. Could be a different one. Anyway, we'll find out. All right, so this has been Deep Dive with Scott. Thank you for hanging out with me for these 2 hours. Sorry I didn't get the RGB Matrix quite working, but we'll pick that up on Monday. Or maybe I'll do a little bit later after the stream, we'll see. Deep dives happen most Fridays. If I'm unable to do it, then I ask Tim, Foamy Guy, to do it, and he does a great job as well. If you want to hang out with me and a bunch of other cool people throughout the week, I encourage you to join the Discord. adafru.it/discord is the URL. Preemptive thanks to DCD for taking timecodes. If you look at past episodes, you'll see timecodes there. That's all thanks to DCD, who's in the Discord chat as well. Thank you all for hanging out. Please, 5.0 is merged in. If you have some boards that's not critical, you want to test it out, we'd love to have you start testing it. You can go to circuitpython.org/downloads and get absolute latest. Should include 5.0 right now and 5.1 hopefully early next week. And then once MicroPython 120 is merged in, then we'll be able to do 9.0 alpha releases as well. If you want to support me, Adafruit supports me really well, so support them by going to adafruit.com and purchasing. Much of the hardware you saw today is developed by them and sold by them, so check that out and support us, please. With that, no cats to pet. Just lots of exciting custom-sized boxes. If these are interesting to you and you don't know, you can go to adafruitplayground.com, and somewhere there's a post on how to order custom cardboard boxes for storing your dev boards in IKEA bookshelves. Yeah, so that's it. Have a great weekend, and I'll see you all next week. Thanks again to Kattni for all